Hello everyone, welcome once again. In our previous session we talked about assessment of risk using a very common and widely used and effective method called as failure mode and effect analysis, FMEA. We talked about why should we use FMEA, because this will help us to prevent the errors that might come during a new design of a process or implementing a process or launching a new product. So we need to be aware of any failure mode in the process that might derail our entire success or entire solution that we have put together. So, and the severity can be very high. So we need to assess the risk in the process using failure mode and effect analysis. We were talking about why do we need an FMEA. If you look into my screen, it talks about how to do an FMEA. So we'll quickly look at it, then we'll get into the process of it. In the how part of the FMEA, we identify potential failure modes for design functions or process requirements. What could be potential design related issues or process related issues in which a process can fail? We assign the severity to the effect of the failure modes, and then we assign frequency of occurrence and likelihood of detection to the potential cause of failure, and then we get a risk priority number, in short called as RPN. RPN is a multiplication of for a product of severity, frequency of occurrence and likelihood of detection, and basis the risk priority number. Higher the risk priority number, higher or bigger that risk. So we are looking at three things here. Severity of the failure mode that can happen, like what could be potential issues in a building while you build it. Theft, catching fire, or it can it can be tilted. Let's say if I talk about the building catching fire is a very big issue, as it would result into loss of life. So severity would be very high. How much high? We'll talk about the scales and so on. Frequency of occurrence will not be every day, of course. It would be once in many years, maybe once in just one lifetime. So occurrence will be not that great, will be lesser. Then the detection, likelihood of detection. How will you know that the building may catch fire? So if you are using bad quality wires, if you are using any MCBs, the building might catch fire. But what is the mechanism for you to know? Unless there is a short circuit and building starts catching fire, we will not know. How can we know in general? If there are fire alarm, smoke detector or water sprinklers which starts when a building catches fire, these will be indicator that a building is set on fire. But if none of these are there in the building, that means there is zero mechanism for you to know unless building catches the fire. So we multiply these different number, and all these severity, frequency of occurrence and likelihood of detection, they have a scale. A typical scale of these three parameters starts from ranges from 1 to 10. 1 to 10, these are three scale. We give a number to all these three and we multiply these three number and we get a resultant. That result is the risk priority number, and the risk priority number, higher the risk priority number, higher the risk. That's a simple calculation here. Let's understand it even further. In the slide you can see it says what is a failure mode, though we talked about it. Failure mode, the way in which the component, any part of the process, input a process could fail to deliver its intended function, things that could go wrong in a process. Failure modes may be the result of upstream operations. So failure mode does not mean it can happen process which is here, it can happen somewhere else. The result is seen here, or the failure is here, but the result is seen later on. So we'll talk about different details about the FMEA. In the next slide, as you can see, we're talking about a form that talks about how to do an FMEA. So in the FMEA, we use a standard form, a standard template that help us to perform the entire analysis. As you can see, this form remains same, and it is used for process failure mode effect analysis. It's also called PFMEA. As you can see in this template, the first column talks about process step. What is the input that goes into a process? We write all the process step, and then the next column talks about potential failure mode. For each step, what could be potential failure mode? In what all ways a process can fail to perform its intended use? The third column talks about what is the impact on the key output or on the business. So if a process fails, what would be its impact on the overall business? And then the next column you see the severity. What is the severity of it? What is the severity of that impact because of a failure mode? The severity will range on a scale of 1 to 10. Number 10 or 9 would mean very, very severe. It can land the business into big issues. Business might shut down. And if the severity is 1, 2 or 3, it is not that severe. It is normal problem. The next column which talks about potential causes. What is the root causes of that failure mode? Of each of that failure mode. And the next column talks about the occurrence. How often does that happen in the business? The root cause that you just talked about, how often does that happen? And again, rating is 1 to 10. If you talk about a rating of 9 or 10 for an occurrence, that means it happens very frequently. Almost every day it happens. And if you talk about a occurrence of 1 or 2, which means it's a rare instance. It doesn't happen every day. And then you have another column called current controls. How will you know that there is a problem in the process? How will you know those root causes that you have written? How will you know any of them? Just like fire I am talking about. How will you know that building might catch fire? If you cannot know it by any chance, then the detection mechanism, again it goes on a scale of 1 to 10. So on a detection scale of 1 to 10, if your detection number is 9 or 10, that means there is no way to know that you can understand if there is a problem in the process or a solution. So it works other way around. Any number high is negative. So 9 and 10 means there is no way to know. But if your detection number mechanism, you rate it at 1 or 2, which means that before it happens, I will get to know. So we give rating on severity, occurrence and detection. And then in the next column, which is RPN, which stands for risk priority number, we multiply the rating given in severity, occurrence and detection. We multiply these three numbers and we get a final number called as RPN. The RPN determines how high the risk is. So in the first column where we saw the number of process steps, each process step will give us some failure mode. So multiple failure modes we'll have and we'll get risk priority number for all the failure modes. And then we'll say which risk priority number is very high and we'll focus on that. As in that will help us to prioritize based on the priority of the risk. So it is called a section 1 or the part 1 of FMEA till the point we complete the RPN. That's the part 1, section 1. Now section 2 starts once we have estimated the risk and their priority and the severity. In the section 2 we write what action should we take to reduce that risk that we just calculated and prioritize. So we write the recommended actions. The next column we write who is the person responsible for completing that action. Then in the next column we write the actual action taken. So you have a recommended action, then you have an actual action which you would take, which might vary from the recommended one. You write that part and then you again calculate the severity, occurrence and detection after some improvements that you have made, which may be after a few weeks or after a few months. And then you again calculate the RPN. RPN should reduce from its previous value. So for example, if the RPN value for a house when it could have caught fire, you are estimating it, if the building catches fire, what will happen? So let's look at the current state. RPN, let's say, comes around 250 because severity is, let's say, 10. Occurrence would be very less. Let's say that's 2, very less. 10 into 220, and detection mechanism almost nothing. There is no way you will know. 20 into 10, 200 you get as the RPN. Now, once you realize this, there is no way we'll get to know the building catching fire, so we have to do something. So you put fire extinguishers, you put good wires, you put MCBs, you put smoke alarm, you put fire alarm, you put water sprinklers. So you make a lot of changes in it. And then you again calculate the severity, occurrence, detection. Now severity will not change here, it will remain as it is. The impact of the fire will always be big. Occurrence from 2 might become 1 because now you have good system in place, the occurrence would be less. Detection would also improve from 10 to 1. The moment building catches fire, you'll know. So now 10 multiplied by 1 into 1 give you 10. So you had a 200 RP and now reduced to just 10. Huge improvement in terms of RP. That means the risk of building catching fire has reduced to a very, very low extent. That's how we look at it. Look at an FMEA. We'll continue with the FMEA. We'll do a detailed example of this entire steps that we just saw in the FMEA template using a very good example, and we'll also explain some of those rating scales also in the next session on the FMEA. Thank you for watching. This is Shivendra Sharma.